So we are live. Let's record this for posterity. First of all, we have to do my traditional who's my favorite student. Good old Anne gets everything right. So what's the official definition of energy? First of all, what are the units for energy? You all need to know this. There can't be dead silence. I'm sorry. And there's going to be some call and response. So wake up, my angels. What are the units for energy? What are the units for work? Yeah, energy is the ability to do work. Now, our first definition of work was force times distance. That means that energy, if an object has energy, it can apply a force over a distance. Number two, what is the minimum amount of work it would take for a student to climb? Well, climbing is like lifting. So, although work is going to be force times distance, when you're lifting, the force you're lifting up is the same size as mg, and we'll call it height. It's going to be mgh. It's going to be 55 times 9.8 times 6. I have no idea what the answer is. It's going to be 55 times 9.8 times 6, 3,230 and change. And the units are joules. Number three, total energy. What the heck do they mean by total energy? I'm going to abbreviate total energy with TE. That's just going to be the potential energy plus the kinetic energy. It's going to be the mgh plus the half mv squared. M is 2, g is 9.8, h is 5. You know what? That's going to work out to 98 plus 0.5 times 2 times 5 squared. You know what? That's going to work out to 25. It's really close to 125. The answer that's closest to, got to be D. Yes, I think. So, using the following graph of force versus position, this is a force versus displacement or position graph. That means the area is going to be the work. It says find the total work done in moving from 0 to 5. That's going to be the area of this triangle plus the area of this rectangle. The area of the triangle is going to be base times height divided by 2. Looks like the base goes 3. Looks like the height is 200 divided by 2, and that works out to 300. Area 2, that's just going to be base times height or length times width. Looks like the base is 2. The height is still 200. That works out to 400. I'm pretty sure we did 700 joules of work. If this represents the work done on a 4-kilogram mass, find the speed of the mass when it reaches 5 meters. The mass is initially at rest. So now we're going to use the concept of work equaling work. What we're going to say here is the area underneath the graph is the change in potential plus the change in kinetic. This question, I like this question, although if I put it on the test, Sean, I would include the phrase level ground, or I would say assume there's no change in the height. You have to assume that here. I would make sure I included that, but I'm going to argue I don't think there's a change in potential energy. Or maybe it said on the previous question, oh yeah, level floor, there it is. Okay, so I don't need to assume that. It did say level floor, which means this meters is not height. Don't think it's mgh. This is no change in height. What is change in anything? Final minus initial. So we have the area, which was it 700? Is that right? That's going to be equal to a half mv final squared minus a half mv initial. Oh, wait a minute. It said it started at rest. Okay, that works. I guess to get the v by itself, it's going to be times by 2, divide by m square root. V is going to be 2 times 700 divided by the mass square root. It's going to be 2 times 700 divided by the mass, square root 18.7. Does that show up there? Hey, there you go. It is A. By the way, the other thing I could do in this situation is give you the speed, VF, and ask you to find the mass. Doable. The escalator is shown, well, blah, blah, blah. The escalator shown below is used to move 20 passengers a minute to the second floor, which is 5 meters above the first. Assume the average passenger is 60 kilograms. What power must the escalator, so power is work over time. Now it's also force times speed. Do you see a speed in this question anywhere? I don't. There is a time, Sean, I was a bit sneaky. There's the time. Yes, time is 60 seconds. What's the work? Well, the work we're lifting, so it's going to be mgh. So it's going to be 60, h is 5, g 9.8. What's the mass? 60 kilograms times 20 passengers. That's the mass. In fact, conveniently, the 60s will cancel. And in fact, I get, is it 1,000? Is it C? Yeah, pretty sure. It's like 998 or something like that if I'm doing the math in my head, I think. Or 980. I could also then say to you as a follow-up, what if the motor is rated for 2,500 watts? What's the efficiency? Oh, got a latecomer. Give me 1 second. Sorry, YouTube, got to interrupt. Number 7, how much work is required to stop a car? Well, the first thing that I said is, nice try, kilometers per hour. Let's see, how do I go to meters per second? I think it's divided by 3.6, yes? So 2.77. Okay. What's this asking me to find? How much work? Well, my first thought is work equals force times distance. Jeremy, do you see a force or a distance anywhere in this question? So I said, okay, I'm not going to use that. It'd be nice. That's the quickest, easiest way. My next thought is it's also the area under a force versus distance graph. Did they give me a graph in this question? No. So I'm going to use the work energy theorem. It's going to be the change in potential plus the change in kinetic. I like this question. I don't like that I didn't say over level ground. We have to assume that, but we will assume that it's over level ground. On the test, I would make sure I included the phrase assume there's no change in height or assume we're on level ground. What's change in anything? Okay, we're going to end up with work equaling a half mv final squared minus a half mv initial squared. Okay, v final is 0. You get a negative answer. Now, I didn't include a negative in the answers to pick from because I think we're just finding the magnitude. But the answer is going to be negative 0.5 times 1200 times, I'm just going to say answer button squared. 0.5 times 1200, Mr. Dueck, times answer button squared. And I get 4,630, is that right? Or am I way off? B. B. Now, it is negative, except the negative is telling me this is how much energy the car has to lose. If you think of it in terms of force times distance, because this force is in the opposite direction of the distance, that also works out to negative. And so you could argue the negatives will cancel if we're just talking about how much work needs to be done. You need to do 4,600 joules of work. Friction needs to, heat needs to gain that much energy. Unless it's an electric car, then you can bleed it off into the battery. Some of it. Example 8. Ooh, roller coasters. I like roller coasters. How fast is it traveling at the bottom? So I think for the first part, that's going to be the initial That's going to be the final. There is a change in height. There is a change in speed. There is a yucky, curvy path. That's a job for conservation of energy. GG. Initial plus initial equals final plus final. Are any of these zero? Definitely at the bottom. Were we starting at rest? No. Okay. So it's going to be mgh initial plus a half mv initial squared equals a half mv final squared. Did they give me the mass? They did. Although, do I need the mass in this question? No. Yeah, the m's are going to cancel in this case because we're ignoring heat. And I'm going to go times by 2, times by 2, times by 2. And I'll get this. Vf squared equals 2gh initial plus vi squared. How'd I get rid of a squared? Square root. I'll get Vf equals the square root of 2 times 9.8 times 18 plus 4 squared, which is Vf squared equals Vi squared plus 2AD in disguise. 2 times 9.8 plus 18 plus 4 squared. Is this going to work? No, this isn't going to work out evenly, is it? No. Is it 7.32 or did I make a mistake? That seems low to me. I added. Something seemed wonky there. It's got to be going faster than that. This can't be a terrible ride. Let's try that again. 19.2, is that better? Okay. Just for giggles, times 3.6. That's not bad. Yeah, I'll stand in line for that, but not for 2 hours. What was it, 19.2? 19.2 meters per second. If you got that, 3 out of 3. Otherwise, I would probably give you 1 mark for that, a half mark for that, a half mark for that, a half mark for that, and a half mark for the answer. But recognizing that it's conservation of energy and not forces, that's worth something. At the top of the second hill, its speed is 950 meters per second. How much energy is lost to heat? Okay, so now it's going to be initial plus initial equals final plus final plus heat. Now my final isn't down here. Now my final looks like it's going to be here. Now there's 2 ways to do this. You can let your initial height be 18. You can let your final height be 10, and you can do the complete solve. The other thing that you can do, one of the nice things about conservation of energy, you can put the ground wherever you want. I'm going to put the ground right there, and I'm going to let my initial height not be 18. What's my initial height if I put the ground right there? 8. What's my final height? 0. I'm going to do that because that way I can go, ha ha. If you didn't do that, we will get the same answer anyways. Now we're trying to get the heat by itself. Heat is going to be a half mv initial squared plus mgh initial minus a half mv final squared. We'll subtract ke final over. Now the mass won't cancel. It's going to be 0.5. Was the mass 1,000? Times 4 squared plus 1,000 times 9.8 times 8, not 18, minus 0.5 times 1,000 times 9.5 squared. Well, that's going to be the answer. No idea what the answer is. Bring out the trusty calculator. 0.5 times 1,000 times 4 squared plus m 1,000 g h 8, not 18, minus 0.5 times 1,000 times 9.5. Don't forget this 9.8, Mr. Dueck. 9.5 Don't forget the squared. Did you all get 41,275 or am I wrong? That's right. No, yes. I need more nods. Sean's nodding. Yeah. So I'll go 41,300 if I go to 3 sig figs, and that's measured in joules. And you would have got the same thing if you used 18 and 10. Okay. If you got that 4 out of 4, otherwise I would give you 1 mark for that line, 1 mark for that line, 1 mark for that line, 1 mark for that line. Number 9. Holly, you going to make it? Okay. Object is pushed across a level surface with varying force as shown below. Oh yeah, I guess the force starts out 0 newtons and eventually climbs to 18 newtons. That means I can't use force times distance. Oh, no, this is a force versus distance graph. The work is going to be the area. Now, it says it starts from rest. What's its final speed? I'm going to assume level ground. I like this question. I like this question. On the test, I would say, or I would include the phrase over level ground. I guess I'm going to start out by saying work equals work. And what I really mean is the area is going to equal the change in potential plus the change in kinetic, although I think I'm going to cross that out. What's the area? The area is going to be base times height divided by 2, and that's going to be a half mv final squared. Why didn't I bother writing minus a half mv initial squared? I'll take that. What's the area? What's the base? 0.9. What's the height? 18. So it's going to be 0.9 times 18 divided by 2. That equals mv squared over 2, or a half mv squared. Let's see. We're going to have 0.9 times 18 divided by 2. I think 8.1 joules is how much work was done. That's going to be mv squared over 2, or 0.5 mv squared. So I guess if I want to find v, it's going to be times by 2 or divide by a half. Divide by the mass. They better have told me the mass. 0.48. That's v squared, square root. Times by 2, divide by 0.48, square root. 5.81 meters per second? Meters per second. If you got that 4 out of 4, otherwise I would probably go something like this. If I saw this line somewhere, I would give you 1 mark. If I saw the 8.1, that alone would get you 1 mark. If I saw that, and if I saw that. If this process is only 66% efficient, what will be the speed? So we assumed 100% efficiency. We assumed all 8.1 joules went into making this car go. If it's only 66% efficient, I guess what I need to find is 66% of 8.1 and then repeat the process. How do you find 66% of something? I can give you a math trick. The word of in math always means multiply, with one exception. The only exception the word of doesn't mean multiply is when it's to the power of, then it's an exponent. I dove into this once. I was bored while I was teaching math back in the day, and I was like, I'm going to see every possible case where the word of is used in all of my math. Couldn't find a single instance where it doesn't mean multiply, except for to the power of. So I'm going to say, I'm going to go times, except is it 66? No, what do you have to do with a percentage first? Make it a decimal. Now I have 5, and I'm not going to round this off. I have 5.346 joules to play with. And now it's going to be a repeat. In fact, I'm going to go back to right here, and I'm going to say it's the same thing, but instead of an 8.1, yeah, V is going to be the square root of 2 times 5.346 divided by 0.48. Oh. In fact, if I'm lucky, I can go, well, you know what, let's just do it this way. 2 times answer button divided by 0.48. I was going to see if I could backspace and get there, but whatever. 4.72, is that correct? Before I go further, I'm going to give you a hint. Don't turn the page. What if instead of telling you the efficiency and asking you to find the speed, what if I gave you the speed? Could you find the efficiency? That's a hint. I think there's a couple of there's at least one version that has that. Okay. And as I've told you all year this year, if I show you how to do something one way going forwards, I can reverse it on the test and feel comfortable with that. I don't know. I'll let you think about it. Well, I guess what you would do is you would know this number, you would solve for that, and then you would backtrack and say, oh, instead of timesing by 0.66, I'd probably divide by, because that would be, oh, I would use efficiency as the smaller number divided by the bigger number. I have the smaller number. I'd like to find the bigger number. Yeah, something like that. Yeah. Sorry? Okay, if you got that, 3 out of 3. Otherwise, if I saw that number, that would get you 1 mark. If you got this wrong, but you tried redoing this, I would give you 1 mark. 1 mark for that. The most common mistake that I see, and it's kind of, I hate to say it's a silly error, but it is. Kids see the points of the 66 and oh, I guess the amount of energy is 0.66 joules. And they just use that because I got to do something. But, um, ooh, from rest, that's probably important. How much energy was transformed into heat? Oh, there's a change in height and a change in speed, and they're talking about heat. I'm not going to do this with work. I'm going to do this with conservation of energy. Oh, this isn't too bad, actually, because I think my final potential energy is 0. We're on the ground, and it did say starting at rest. Oh, 5 marks for this. This is going to be a little nicer. Heat is going to be mgh initial minus a half mv final squared. No? Trying to get the heat by itself, right? Wouldn't I move the KE final to there? I think. Had me worried for a second there. Heat. Do the M's cancel? It's not an M in heat. Let's see. 160 times 9.8 times 42 minus 0.5 times 160 times 24. Don't forget the squared, Mr. Dueck. 160 times 9.8 times 42 plus minus 0.5 times 160 times 24 squared. Did you get 1,980? Sorry, 1,000. Sorry, let's try that again. 19,800. That's what I meant to say. Okay. Here, 5 out of 5 if you got that. Otherwise, really, I did it in 4 lines, so I would probably go 1 mark, 1 mark, 1 mark, and weirdly, 2 marks for the answer, I guess. What's the average force of friction? Well, I also know another way to think about heat is the work done by friction. That's going to be the force of friction times distance. I guess friction is going to be heat divided by distance. It's going to be, I want to use the full value, 19,776 divided by which distance? The distance that's in the same direction as friction, which in this case is the 120. Divided by 120. Average force of friction, 164.8. I'll call it 165 force, newtons. If you got that 2 out of 2, otherwise I would probably give you a half mark if I saw that. Really, I would give you 1 mark if I saw that you were dividing the heat by the distance, and a half mark for the answer. Ooh, a bonus question. Ooh. What's the coefficient of friction along the ramp? Huh, that's a good question. Well, friction is mu times the normal force. I guess mu is going to be friction divided by the normal force. Well, I just figured out friction is going to be 164.8. I don't know the normal force. You know what? This is a job for a free body diagram. Well, what did you say? I saw you. It's going to be mg perpendicular. It's going to be 164.8 divided by mg of cosine is. The problem is I don't know theta. Or do I? How can I figure out angle theta? Well, I have a triangle that looks like this. 42, 120. Theta, I can figure out theta. It's going to be opposite hypotenuse. You know what? Sine theta is going to be 42 over 120. Shift sine of 42 over 120. Theta is 20.5 degrees. So I can walk that down here. $20.5. It's going to be 164.8 divided by bracket m. What was m? 160 times 9.8 cosine. Answer button. Let's do that. And I get a mu of 0.112. So I'd give you 2 bonus marks for that. I would probably give you 1 mark if I saw that. Half mark if I saw that. And a half mark for the answer. So this quiz has the opportunity to be out of 30. Well, it's out of 28, but you can get up to 30 out of 28. Let me pause the video.